everybody? Everyone back at home, or where are you? You can let me know. At home ka, in campus ka, or in rumah sewa ka? Okay, at home. Good. Okay, selamat berpuasa to everybody. So for this semester, myself and as well as Prof. Dr. Jane Nabadin will be teaching this course. This is a second time we're offering this course. The first one was last cohort, last batch in semester 2, 2023, 2024. So you are the second batch. Right, so for this class, we're going to start in 2 minutes. So this class, I'm going to go through with you the practical approach. Please get the slides for this practical one in eLib course page for you to refer to what we're going to do today. Right, so since this is online session, it will be a little bit odd to do a practical session during online, but we have to do it this way, this time around, because we'll be doing tutorials onwards with Prof. Jane after the second week. Okay, so I only have week 1 and week 2 to do this practical approach, but we'll be going back again to practical approach after I take in the lectures in the maybe few more weeks. After probably week 7, week 8, I will take over some more lectures related to AI programming and also deep learning and also knowledge base. Yeah. Okay, so right. So I hope if maybe some of you will be referring to your tablet to look at the hands-on instructions, or if you have second screen, that'll be nice as well to refer to your second screen, so that you can do the practical on one of the screens and refer to the demo that I'm going to do on the other screen that you have. Okay, so we are almost reaching to 33 students. So everybody is on your final semester. Good, right? So now you're doing your FYP2, FYP2. Everybody already started your implementation? Yes, no? Yes, okay, good. So hopefully you're on the way, okay, on the way to finish your FYP. No more holiday, even though there are many public holidays this semester. No more holiday for you. You are on your last league, I would say, your last part of the league to finish your final year. Okay, you can burn your midnight oils as many times as you want to complete your final year project, because I believe that at the end of this semester you will have a symposium. Symposium will be very interesting, I hope. The last time was very interesting. We get to see students work physically, and you get to demo your work to your friends. Your friends can test or try your applications and maybe see the results of your research. And then, all this you can do knowledge exchange between one another. So it'll be very interesting for this semester. I hope to see a physical symposium again this semester. So you have to work hard towards that and make your application work. All right. So you can start to cry this week and then stop to cry on the 14th week. Okay. So there are 30 of you. Probably I have to start. It's already 12 o'clock. Okay. So I'm going to close my camera so that I'll reduce your bandwidth to receive my bandwidth. Wait, hold on. Let me go through. Let me open something first. Okay, how do I? Okay. Okay, so going to the okay, let me close this first. Going to your eLib course page first. I have prepared the practical one over here, so please download this. Okay. For this practical approach, I will be using Google Colab. If you have used Jupyter Notebook on your Visual Studio Code, that's fine. It's up to you, okay? But I'm just going to use Colab so that the rest who do not have Jupyter Notebook on Visual Studio, or you find that it's quite difficult to use that, then you can use Colab. Okay, up to you, up to you. Whatever editor you want to use, as long as notebook type. Okay. Okay, so if you go to course information and resources, go down here. There are a list of data sets which I've already uploaded. Very small ones. There's not really big. Once you go to AI programming later on, I'll give you a bigger data set. So you can download all this. Okay, so there are 3 data sets. One of it will be used in the practical. This mental health sentiment is being used in the exercise. I will upload the exercise at the end of this class later. And the first one will be something interesting. I will let you know maybe next week. So please download the students.csv. You can put it into your apa nama ni? To your machine lah. Okay. Now, how do I close this? How do I? Wait, hold on. I'm not really good in this MS Teams. Let me stop share first. All right. Okay, let me reshare this again. Okay, PDF. Okay, so can you see this? This screen on this, I think you're looking at the slides. Yes, no? Yes, okay. Right. So, so this practical one is related to recap on Python and Jupyter Notebook. I've discussed with Dr. Chiu Kang Leng, your lecturer for computational science lab. So he said that he already teach you the fundamentals of Python up to integration and also interpolation with some libraries. You can also let me know what you have already learned in the CS lab so that I can know better what you have already learned through that course in terms of the practical one. What else do you learn before this in CS lab or Python? Jangan malu-malu, ah. Ingat-ingat lupa. What do you learn in CS lab for Python? Anybody? 33 of you here. Graph plotting, okay, pandas. Matplotlib, okay, good. SciPy. I hope you don't look at my slides. Okay, right, that's good. So you've used pandas before. Right, so, and also SciPy, okay. Right, so for this course, maybe you learn maybe 1 or 2 more libraries related to machine learning lah, basically for AI, okay. Okay, so let's go to the objectives of this practical. Basically, I want you to recall back your fundamentals of the Python basics, including data structures, functions, and also loops. And I will go through a little bit of simple programming on using the NumPy and also the pandas for data manipulation. Okay, and maybe one sample on how to use the matplotlib. There are many ways on how to use the matplotlib, and also the Seaborn actually helps you to further investigate your data even better is actually using a little, if I'm not mistaken, it's on top of the matplotlib. You still need to use the matplotlib, and Seaborn is like diversifying what matplotlib can do. And then just a recall on how you can use SciPy for computation. I guess you already do integration, and we will recall back on how to do interpolation lah. Okay. So just two things that we'll cover for this class, which is the fundamentals and also the SciPy recap. Okay, so as I mentioned just now, you can use Google Colab. I think I've already announced in the MS Teams that you are eligible to subscribe to another Google Workspace under the Unimas email account. Okay, so if you're already signed up, that's good. You can use that space for you to do your extra programming, because I'm not so sure. Can you guys let me know what is the space, how many GB you are given for this one? But because I got 100 GB, I'm not so sure for student. I think it's 50. You can let me know if you already signed up. Anybody signed up under the Unimas Google Workspace? Sudah ke belum? Sudah tak mau? Sudah. Okay, what's the size? I haven't checked. Okay, maybe later you can check now. Okay, so yeah, use that for the remaining 1 year that you have for your experiment guide, etc. Okay, this is good. Right, so why I want to use Google Colab is that I use it for my research once in a while. If I feel that the Visual Studio Code, maybe my machine is not supporting my programming, and it's free to use. There's a asterisk there, biasalah, free to use at some point. It's a cloud platform where you can actually share your codes with other people when you want to do a collaborative project. You can share your codes together, and then you can update your codes together. And it is basically for the purpose of machine learning and data science. And it gives you some free access to GPUs and TPUs for a certain time. I'm not so sure what is the maximum number of hours that you can use the GPUs and TPUs. The last time I checked with my student, it was after like 2 hours. I think they already stopped, and then you need to restart again in the next 1 hour. Previously, I think 2 years ago, not 2 years ago, before COVID, when I used this Google Colab, I could use the free version of the GPUs. That time there was no TPUs yet for under Google Colab. I can use up to 12 hours to train my model. So what's those GPUs and TPUs for? This is good for you to try out deep learning models. You want to try out pre-trained models, or you want to train your own deep learning model. Then you can use GPUs and TPUs. Okay. Which one is better? It really depends on your deep learning architecture. So you have to test and try lah. Okay. And as I mentioned just now, is you can easily collaborate with your peers. No setup required. You don't have to install Python package like what you need to do when you use Visual Studio Code when you work on your local machine. So basically, that is why I'm using this for teaching. I don't have to teach you how to install the Python package, how to install the libraries. Well, some of the libraries are not added. If let's say Google doesn't add that library, then you have to, not physically, but you have to have some extra codes to install the libraries. Okay, maybe some of you already know this part already. Okay, and it's really best for learning, especially you want to go into data science and also artificial intelligence. They've already included the Gemini AI, but at some point it's not so reliable. Really depends on the prompt that you're going to use. But yeah, this one is up to you. You want to use it or not, but you have to use it with smartness, I would say. You have to be smart when you want to use AI. Don't trust fully what they tell you. Okay, you still need to understand the codes. why it happened like that, and why did it use that function? What's the purpose? That's how you actually improve your learning, okay? And it's ideal for research and development. Okay, right. So let's go into the first part on the fundamentals recap and also data handling. This is just to refresh again what is Python. Okay, so it first introduced in 1980, but officially launched in 1991. So there are many built-in functions and libraries that are the first choice for data scientists. Of course, in terms of the performance, when you do Python programming, sometimes uh, other languages like C++ can perform better when it comes to computing. But it's still the first choice for data scientists who wants to come up with results fast. They want to analyze data fast. They don't care about the performance. They really just want to try to understand and to manipulate the data quickly. Okay, so if your requirement is that, then Python is the way to go. But if you want to develop an application that does this computing and performance is your thing that you want to optimize, then maybe Python could be something that you should not consider first lah. That will be on the engineering side. It is privileged with inbuilt functions where you just need to just call the function name and then just use the parameter. It's very similar to MATLAB, where you don't really have to declare the variable. You don't have to declare that, okay, this variable is only dealing with characters and etc. So you can change as you go. And it is the most convenient and popular language to handle big data. So if you're handling big data, okay, Python is something that you should consider. If you're building applications, websites, I think, I don't know, there are many school of thoughts about it. So you have to consider the advantages and disadvantages of this language when you want to solve something, okay? Right. So important packages that are related to AI data science, as I mentioned here, not limited to, are the ones I listed here: the pandas, the numpy, the scipy, the scikit-learn. Okay, so we will go into the scikit-learn when we get into AI programming. Maybe some of you already started to use this for your research, or maybe during your internship you already learned how to use the scikit-learn. And then we have the matplotlib for data visualization, TensorFlow, Transformer for deep learning models. There are other things as well, other libraries that are not mentioned here. Probably we will learn that along the way, or you discover that for your project or assignment. You as learning this AI for one course is actually not enough. So we are going to give you some brief introduction only, and then we let you to discover. And if you're looking into data science, this is what computational science students are actually doing. You are very close to data science because you actually cover all the things that have been mentioned here. You know in depth about the math and also statistical problems, and you know how to compute these mathematical and statistical problems into computing based on your computer science knowledge, and then you can apply this knowledge, your math and also computing knowledge into any domains and maybe some business areas, okay, or knowledge. So you're in a good place. Okay. Right, so let's go into a quick overview of the Google Colab. You can sign up, open up your Google Colab, or you can open up your Jupyter notebook. If you cannot remember how you're going to do this, we're going to do this together. Okay, so this is the first hands-on. You search Google Colab and sign in to your Gmail account. If you're using the Google Colab, open your Google Colab and also your notebook. And then I want you to start to add the following markdown cells. I've done a little bit of this, so I'm going to, hold on. Open the other one. Okay, this one. So I'm going to split my screen into two like this. Hopefully you can see the slides over here. Hopefully it's not too small. So on the left side of my screen here is my Google Colab. Maybe we go through how this Google Colab actually looks like. Okay, so you have on the top part over here will be your menu. Okay, and after you open up, you can rename your IPYNB notebook into something like this, practical 1. Okay, then we have your file, edit, view, insert, runtime. Okay, so runtime is important because sometimes when you do AI programming or you're trying to run a model or train a model, maybe you did something wrong, so you have to know where you can stop the runtime. So it should be here. We can even change the runtime type. So changing the runtime type, it depends on the language that you're
So
going to use. Yes.
we cannot see your other.
Oh, right. So sorry. Let me stop share that. Oh, Kevin, only 10 GB. Is it? Oh, too small. But anyway, maybe let me stop share this first. Reshare this again. I'll reshare my screen. Okay, can you see left side and right side?
Yeah. Thank you.
Okay. All right, thanks. Okay, as I was blabbing just now. Okay, so we go to this runtime. You go to, let's say you want to change the runtime type. So these are the types of runtime type. They've offered quite a number of things. R and Julia. I have not tried Julia. Sounds interesting. So they've already added Python 3, R, and also Julia over here. You can change it. So I suggest that you use CPU. If you use GPU, you will keep on getting messages saying that you're not using the GPU. You're not using the GPU. Please release me. They're trying to say that because maybe there's some other people in the world that wants to use the GPU and maybe they're on hold or something like that. Okay, so but if you already want to start to do a deep learning model, you are using deep learning models which cannot be handled by the CPU, then you can change this to GPU. Then you have to restart your runtime again, run everything, and then start to train. Okay, I have not tried the TPU yet. Yeah, there are some limitations on the free access to this. So if you want to buy the compute units, you can do so. But for me, I think it's quite expensive lah. I've tried it before. I tried to do speech recognition modeling, and it cost me quite a lot, and then I couldn't really finish the training. But if you want to try, you can purchase. Up to you. So there are other versions. Meaning that if you go Pro, the Google Colab Pro, when you purchase those units, then you can change to test on other GPU. So A100 GPU is one of the best GPU used to GPU for AI machine learning lah. Okay, so up to you to explore. Right. So when you go into tools, you go into settings. So this is where you can ask for AI assistance if you want to switch on the Gemini AI. So I suggest that you can do this on your own, but during this practical session, switch it off because it's quite annoying also to see those suggestions. Okay, so when you do your project, up to you. You want to use this Gemini AI, it's up to you. As I mentioned just now, you have to put your smartness on how you're going to use this AI to help you to solve some problem. Okay, so because you can't really trust what they not trust, but you can't really accept 100% of what they give you because sometimes it will give you a different results or not the one that you're going to use. Okay, that's why there is a remark here: use code with caution. Okay, so up to you. So for me, I'm going to switch off everything. You can switch off as well if you want to. At the same time, you can also connect to your GitHub. So sometimes coders, they want to save their versions on GitHub for publishing purposes. They want to publish their collab or maybe notebooks to others, so they can directly just upload into their GitHub without signing up to GitHub on the external web browser and then upload over there. So over here, they just immediately can connect to the GitHub and save their latest version project. Okay. Other things over here, you can see the Gemini, and then you can also connect to your runtime over here. And also, if you want to use your machine, let's say you have a server or you want to use your machine to use this Google Colab, it's kind of, I'm trying to control myself. It's kind of ridiculous. But sometimes you do need to use this runtime. Let's say you find that I want to use this Google Colab, but I want to use my server, which is very powerful with GPUs or TPUs, so you can change your local to a local runtime. But most of the time, you can use your own VS Code lah, because you have your Jupyter Notebook. You connect your machine je lah, right? Okay. But yeah, why people want to use Google Colab as well is it's a Linux because Google will use servers based on Linux architecture or operating system. So things are much more simpler to do when you're using Unix OS lah, okay, or Unix OS rather than if you're using Windows, because one command lines are a little bit different, so those things matter for some researchers. Okay, all right. So over here, you have different types of command palette that you can actually see, okay, whether you want to add text or add comment or whatever. And over here, we have a plus code. So this is where the nice things happening. So you want to add a programming code, then you can use a plus code and then this thing will appear. So this is where you put your Python codes over here, okay? And you can move it up and down wherever you want to place it, and then you can delete it, okay, if you don't want to use it yet. And then you have the plus text here. This is very nice if you want to make nice notes to your Google Colab. You can give good instructions, to someone else that wants to use your Google Colab, or you want to make nice notes about what you have done over here. So I've done one, which is the title of this practical one. So if I double click this, and then this will change into the editable version of this text corner. Here you can toggle the heading, whether you want to do this as a main section or subsection. Why this is matter, if you go over here, there's a 3 dots over here, you can look at the table of contents, and then you will see all your contents here very nicely done for you. Okay, so here will be my main section, and then on the second one will be my subsection. So this is what you're going to do after this, which is to do the labeling of the subsection. So if you look at hands on one, do the following markdown cells. So I've done one, which is number one. We're going to do the variables and data types. So next you can label this. Click twice to make a subsection. Highlight this to remove that label, new section, and you can call this as loops and conditional statements. So you should know what this is going to be about. And then you click somewhere else to move away. Oh, I forgot to put the number. So you can click here like that. Okay. So then you have a second subject section. Then if you want to, let's say you want to copy that cell and then you place it somewhere here, also can. You can double click that, highlight, and then rename it. So the third one will be functions and these comprehensions. Okay. Then click somewhere else. All right. So now we have already labeled that. So that hands-on. Very, very easy. Okay. Next part is related to the basics. Okay, so hands-on 2. Now we're going to the variables and the data types. Okay, so you want to add some codes over here. Okay, whether you want to move this up pun boleh, you want to create a new cell pun boleh. So this is where you start to do your coding. So try to do this. So if you want to create a variable for num, then you just do this, press enter. Okay, and then if you want to run that particular cell only, you can click on this play button over here. So it's very simple, and then just run. It will take some time because we are on this doing this cloud. Okay, if you're using your own machine on your VS Code, then it'll be very easy. So yeah. Then you can continue. Let's say pi, this one is, oops, not negative. Pi equals to 3.14. And then we're going to do a text variable. So you can use double quote, yeah, to indicate a string, okay, for text variables, just like that. And then the next one is related to putting this as a data. Okay, maybe I stop here first and run this cell. Okay, run this. And then if let's say you want to print, very easy, call it print, print num. Okay, print num, run again, you have a 10. Okay, so if you don't want to mix between creating the variable and printing in the same cell, so you can separate and add another code over here for you to do the printing separate. So let's say you don't want to cut out this part, so this is creating the variables, this is to print your results. So you can do that. It's very easy. Okay, so right, so let's continue this. Let's go into creating our list. So creating a list specifically on Python is very, very easy. I think this is similar to MATLAB. Correct me if I'm wrong. Okay, so we are just established like this. So this is a list. So this is something like a vector as well. So you can create your list. You want to print that list. Oops. Oh. Okay, so something that is nice over there is that collab can help you to recall what you want to print. So this is what you have already printed. You have your list there. Now, if you want to create a tuple, okay, now you can print the tuple. Whoops. Then you can print that. Okay, so that's how your tuples look like. Then if you want to build a dictionary, then you can use open bracket and close brackets. Please use the correct brackets, yeah. If you want to build your dictionary list, you have to use the right bracket. That is very sensitive for Python. Then you just continue creating something like this to have a list, to have a dictionary that has the value for category name and also age. Okay, this is number. So you can mix this between string and also number. Okay. So these are the things that you can do. Okay. So and you need to differentiate between what you want to actually instigate here. You want to create a list, you want to create a tuple, or you want to create a data dictionary. Okay, I think it's the same for C++ as well. Okay, and if you want to create a Boolean version of a variable, you can also indicate very easily like this. Okay, so that's the only thing that you need to do. All right. So if you want to look at the type that you have done just now, maybe I don't put this together. Let me run this first. Create another cell. We can print the type of variable that you've already done just now, or you want to look at what is the type of variable that you have already added, like for the list or the tuple or the dictionary. So let's say you want to look at the list. Just in case you forget, okay, what is the type of variable that I've already created just now? Was it a normal variable? Okay, here we have a integer type, you have the string type, and then you have the list type. So that you remember, and then you know maybe what's the problem? My code doesn't work. Oh, this is a list type. Oh, it's a tuple. So, right. So I have a question here. What's the difference between list, tuple, and dictionary? When do you need to do this? Ni semua programmers ni. Mesti tahu dah. What's the difference between list, tuple, and dictionary? Can I have Vincent Chu? What's the difference between this? List, tuple, dictionary. Don't ask ChatGPT, yeah, you should know. Who can help Vincent Chu? Come on. Mari jawab. Vincent Chu, you there? Someone ping Vincent Chu. Where is Vincent Chu? Wanted. Okay. Can I have maybe can I get Michelle Chang? Michelle, you're there? Okay. Tak boleh senyap ni. Fofia dah. What's the difference between list, tuple, and dictionary? Michelle, you there?
Hello.
Yes, hello. What do you think? What's the difference between the list, tuple, and dictionary?
List and tuple can be duplicate, but dictionary cannot.
List and tuple can duplicate? Duplicate how? What do you mean?
Like dictionary key must be unique, but list and tuple no need.
Dictionary must be the key, okay. The key must be unique, okay, true. Okay, thank you. Maybe my next question would be, can you change tuples? Can you update tuples? Can I ask Patrick Owen? Can you change tuples once you've already define that tuples? Can you change the values of the tuples? Okay, good. You cannot. How about list? Can you change the values of list once you create a variable of list? Okay, can. So this thing is very important. That's why if you want to create a variable of something that has more than one input, you have to think, are you building a list, or are you building a tuple, or are you building dictionary? Because the way that you build those variable and then the way that you process them will be totally different. So you need to establish that. This is very important. Okay, basic ni, basic. Budak Fofi apa tu tahu. Okay, let's go into hands-on 3. I think we are still under variables and also data handling. Okay, so create another cell. You can code. You can create a cell over here on the Google Colab. So I want you to create a dictionary to store these details of 3 students that you have on the right side. You look at the table here. And then I want you to process it to print the second student's name only the name. Huh? So the sample output I have given here is something like this, where you call the name of the second student. Okay, so if you see over here, there is the value 1 over there. This is because the index understood by Python starts from 0. Some language understand index starts from 1. So the index for the Python is 0. This one you have to understand. Huh? When you are looking at second student, which means your index should be 1 lah. All right, so let's try to look into this. Right, you can start to build your dictionary first. Okay, on your new cell. Okay, so let's say you start to code in my keyboard. Depan sikit. First name is Julie. So you can call first time this variable called student data. I'm going to open the bracket. Okay, going to establish the student 1 detail first. Let's say we're going to use this way, student 1 detail. And in this student 1, we have some other more details under the student 1. We call it name. And then this name, we already have Julie John. Okay. Right. Then finish that with a comma because we need to add some more value. Put that back. So we have age. Then you can establish this as the number. Then we put this as a comma. 12, 23. 23, comma, then we establish the program. All right. Let's say we call this as another string. Network computing. Okay, so this is establishing the first student. So you can stop here if you want to. Click. Okay. Then if you want to print the output, you can do so. Print student data. So you have your first student. All right. So let's say you want to update the dictionary that you've already established. So we're going back to the previous cell just now. You can also use the same variable that you've already established, and you use the update function. Okay, so Python is an object-oriented type of programming, so it's easy to use the other sub functions. Okay, right. So in this update function, you're going to add student underscore 2 for the second student details. So you open another bracket. You can do name. Okay, so here we have Muhammad Ali. Ali. And comma, we put age. Because we have values over there. Then over here we have the program. So you must use the same key that you've already established in the first time that you've already established the dictionary. Okay, so this one is computational science. Okay, then click on play. Okay, so no error. If you have already played that cell and you saw an error, which means that you did something wrong. So let's say you want to print out the new list of students or the dictionary for the students. Hopefully you'll be in. So now you have student 1 and then student 2 data. Okay, so that's good. Now let's say you want to add another one. Repeat the same way using the update function. Okay, so I'm lazy. I'm just going to copy this. I don't do mistakes. So copy that. Going to put here, call it student 3. Change the name. Change the age. And call this as software engineering. So I run this again. No error. So now I have up to student 3. Okay, so this is how you can try to build your dictionary repetitively like this. Of course, this is not efficient. Of course, okay. If you're already a smart coder, you feel like, oh, this is so not efficient. There should be some other ways to do this. Yes, there is. We'll go into that later. All right. Any questions so far for hands-on 3? All right, we were not done yet. Sorry. Details of the 3 students done. Now we want to print the function to display the second student's name. So here we can print all of the students' name. Now we want to print only the second student's name. So you use print student data, and then you have to be specific of which key that you want to print. All right. So if you open the bracket, you will see here there are many lists that you can actually select and then see whether these are all what do you call that? What you want. But over here, we want to print only the name. So let's say we call this as name. Okay. Oops. Oh, wrong bracket. Okay. Name and then second student. So print this. I did something wrong. Oh, I need to call student. Sorry. We need to call student first. Student 2. Open another bracket. Name. And then this is 1. Oh, I don't have to do this. Oh, I think I have to update the slides. Okay. Something like this. Did I do this right? Yes, correct. So if you look at the second line over here, so ignore the first one. Let me rerun this again. So if you want to do a comment, you can just do like that. Put the that symbol there. Okay. And you can print the second student's name. Okay. So just use student 2 and name. So ignore this one. I think I have to update the slides later. Right. Okay. So this is hands-on 3. Okay, so to print the student's name, second student's name, you should call the student 2 first. Okay, and then you should call the other key. Right. Next, if you go to hands-on 4, so this is to learn about the loop. So let's go to the second part. Okay, go to the second section. You go into loops and conditional statements. I think this is very easy to do. I think this is maybe similar to MATLAB codes. Just if you want to just do a simple loop, you just say, okay, for I in, you want to generate some simple range. Let's say we start with five numbers, okay? Then print all the 5 numbers, for example. So if you want to do this, you can use the F function to print out all the iteration of those values. Okay, something like that. So every iteration will print out all the values. So if you click on this print, so you will have the values starting from 0 up to 4, 5 numbers. So the range here typically if you use just range like this, okay, put range 5, which means you want 5 numbers. So it will start from 0 until the 5th number, which is 4. If you put 1, 5, it will give you a different thing. So it will start from 1, 2, 3 until 4. So this is the range starting from 1 to 5 in between. It does not include 1 to 5. So there are other ways on how to include the numbers that you want. Okay, so if you want numbers from 1 to 5 to be printed, the upper bound is not included. Okay, so if you want the number 5 to be printed, so you have to set the upper bound to be 6. Okay, so from here, you start from 1 until 5. So you should know. All this you have to test and try. Okay, so doing this for loop is very simple. So this line is for you to print the iteration line by line. Okay. Now let's go into if else. If else ni biasa lah kan. If you want to check the condition. So here we have a sample here to check whether if that age value is more than 18 or not. So if age is greater or equal to 18, then you check. So the indentation is already done for you. So you print some notification maybe. So you can call it eligible to vote. And then you can put an else statement. So make sure indentation is correct. Okay, so if else should be the same indent. Then the other things should be in a indentation. So here not eligible to vote. Okay, then you click on run. Right? Any questions so far? So far so good? Okay, I assume the silence to be good. All right, so let's go into the hands-on 5 over here. So here we're looking at writing a loop that prints numbers from 1 to 10. Yeah, this one very easy lah. But replaces the multiples of 3 with AI, the word AI. Right, so let's try to generate the numbers first. Okay, so we want to generate the numbers. Okay, first we need to write the loop code. So we can use for I in. If you want to use for J, for K, for M, also fine. It's just a variable that you need to establish to keep the numbers that you want to print later. Okay, so let's say you want to generate the values 1 to 10, so which means your upper bound should be 11 to make it simple. Okay, so let's try to print those values first. So print I. Okay, just want to make it simple over here. So click on print, click on the cell. So you should have all the values that you want to be printed. So now you have the numbers printed 1 to 10. Now you want to replace the multiples of 3 with AI. So which means that the value 3, the value 6, and the value 9 needs to be changed. There are many ways on how to do this. You can do direct intervention, which means that if you find that the value is 3 or 6 or 9, then you can replace those numbers. Okay, let's try to do that. Let me try to remember that. If I is equals to 3, or I think it's like that. I is equals to 6. Can I do a double or? Let's do something that I never tried before. Okay. 9. Then you can say that I is now changed to AI. This should not be there. We need to remove that. No printing initially. Okay, so yeah, I'm just gonna do one if. Let's say we're gonna do this. Yeah, run this. Okay, it works. So I didn't use else. Yeah, you could though. You could. We could do something like this. Print I, and then you do an else. Let's say if it is to do an else, then you can do something like that. Okay, so run it again. Then you can get something like this. Okay, so you can do double logical operator here or in one if statement. Interesting. Okay, this is a very manual intervention. Okay, so this is something that maybe you can do like hard-coded type, but this is not efficient. Okay, so let's try to do something that is more efficient, which means that you want to understand the concept here, because it says that every multiples of 3 with AI. So if you remember your discrete math, I hope you remember. So we have this function called mod, okay, whereby if you have a value A, any value A mod 3, if let's say you divide A with 3 and it gives you a remainder 1, 2, and 3. So you don't want that. You want a remainder equals to 0. So for example, if A is equals to 3, 3 mod 3 will give you 0. 6 mod 3 will give you 2. Sorry, 6 mod 3 it will give you a 0. So because you want to have something that is giving you a remainder. Basically, we're talking about remainder here, remainder of 0 wherever you divide that value with a number, for example, 3. So we use that concept to try to process our data. Data here is the value that you generate, I from 1 to 10. You divide that, and then you want to change that to the word AI. If when you divide it by 3, you don't have a remainder, so you want to print like that. So let's try to change that code. So we type it again over here for I in range 1 to 11. Okay, now we're gonna do if I, that is the number of the constant number that you want to use. If I, then you take the percentage 3. It looks odd, but this is what we do for to do divisibility, Okay, remember your discrete maths. So if that value divided by 3 gives you a remainder of 0, then we're going to choose, we're going to change I to become AI. Then we can print that I. So let's look at this first. So we're printing all those values I. So we want to see where did it go over here. So let's complete this if else. So we print I. Run this again. Okay, so we get the same pattern that you see on the top there, but this one is be more efficient. For example, the question asks you to write a loop that prints number 1 to 10, but replaces the multiples of 2 with AI. So from this code, you can just change the number number 3 to 2 and do the same thing. So just run it and then you get the values already. If let's say you multiples of 5, then you just change one value only in your code, run this, and then you get a different value. So this is more efficient compared to the top here, where you have to think first, what will be the multiples of 3 that you should change to the word AI, okay? Right, so this is something that is you can learn about coming up with efficient programming. So let's go into hands-on 6. This is related to using the square functions, I think. Okay, so now we're looking into part 3, doing the just using the functions available, simple functions in Python. So over here, we are looking at defining a function. So defining a function, not using simple functions in Python, sorry. Defining a function, sorry, don't define function like that. Okay, so here we're calling a square function. Assuming the square function is not available in Python and you want to establish the function, so we use DEF. So DEF is the module in Python where you tell them, okay, I want to define my own function. So you do it this way. And then you want to return a value after you do some multiplication or some processes in the function itself. So here we're doing square function, which is simple. So a square function, we can use the double star there to indicate that this is a square function. Any number as an input, and then you get a power of 2. Okay, a power of 2 using the double star over there. So to use this function, that you can call it, let's say A is equals to square, because we've already established that. We can do it in the same cell. It will run sequentially, no problem. Then we're going to print A. Okay. Do that, and then you get that result. So if let's say your input is 15, then you run this. So it's efficient. So you can use this function many times in many times in your code. You can also use this function that you've already established in different cells. So it runs sequentially. If let's say you did not run this cell at the beginning of, let's say the first time you open this this notebook, collab notebook, and then suddenly you want to run a cell that has A is equals to square 12, for example. If you run this without running this, the previous cell, it cannot work. Okay, so because it works sequentially, you need to run a prior knowledge, we call it prior cell, that needs the function that you need to use in the second cell. Okay, so because you already run this, that's fine. So now you can run this A and then print it again, and then the A will be updated based on what you've already done in the previous one. Okay, so you have to be careful with the variables that you use. Make sure you remember which variable that you want to actually print out or process. Okay, right, so now let's go into list comprehension. Okay, so this is about how you can manipulate Python to read your list efficiently using this very simple one-liner code, which actually you need maybe multiples of lines of codes prior to this, the one that you have on the slide. Maybe before I go into this list comprehension, I will try to do the same thing that it tries to come up with, which is we want to produce this output using square numbers, okay, which is using the power of 2 over here. So the output is 0, 1, 4, 9, and 16. So we want to come up with this value. So first, let's say we want to define define an even number function. So I put a note here, define return even number. Okay, so this is just a comment here. So we define it, so we return even numbers given some input. Okay, so let's write this function first. Okay, so let's say I call even as a list, but I put this as an empty list first, because we want to produce all these lists of numbers. It's good to establish an empty list. Okay, so this is to create empty list every time this function is being called. Okay, so now what I want to do is to see if from the numbers given to us as the input here, for each of that numbers, I want to return even number. Okay, I want to return even number, or I want to return some outputs lah. Okay, some outputs first. So let's forget about these outputs on the slides. Okay, not looking at this output, but we'll get back to this later. So what I want to do is to come up with some values first. Okay, so we want to return some even number, let's say, using this function. So let's go into coming up with that for I in numbers. Oh, sorry. Num. Okay, so these are the list of numbers given to you. So if let's say we check that, okay, even number, which means if the number is divided by 2, it should not give some remainder. Remainder should be 0, so that will be an even number. Okay, so from there, I want to append my list with that number that have been processed just now. Okay, so even equals to empty list just now will be appended with the X values that we've already processed. If that value doesn't give you a remainder, then therefore that number is an even number. So yeah, we're gonna do that. Else we don't care. We just want to return even number. So return return even. So let's look at this one. Let's say to use this function, some example here. Let's call numbers to be some list of values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me finish that. Okay. So from here, let's call our even numbers function. So this is a variable. Then we're going to call return even numbers. So then our inputs will be the list. And then I'm going to print the even numbers. Okay. Run this up. X is not defined. All right. Oh, I in num. Oh, X. Sorry. Why do I have to use X just now? This should be I. Run this again. Appropriately. Oh, I'm using X again. Oh, sorry. This should be I. Okay. So what happens here is that we have a function that we've already created. And these are the lines of codes they're going to need if you want to process whether the number is even number or an odd number, etc. So these are the lines of codes. So let's compare to another line of code that I'm going to show to you where it is done just by one line. Okay, so the idea just now is to come up with even numbers from a list of numbers, right? So by doing so, we still need to define the function again. So I'm going to copy that. So define here return even number function participation. Okay, so we're going to define it again. Okay, so define the function. Maybe I put here return even numbers 2 so that we can see the difference between the two. So one line of code is to just return this instruction. Let's say I is the number that will be processed, and then for I in num, so the num here will be the list. Okay, so this is not done yet. So for each number, that is given to you in this function for I in num, we will process that I number. Okay. Here we want to check whether that number I tadi is an even number or not. So we're going to use the same equation that we have used at the top as a case of checking the condition. So here we have the iteration for I in number. If I is an even number, then it will return the I. That's it. Okay, let's run this. Okay, everything okay. So now let's utilize this function. Okay, so we are going to copy the same. Because I'm so lazy. I'm copying this. Going to change the function a little bit over here because I call this as even numbers 2. Run that, and voila, you have a very you have the same number here, 2, 4, 6, 8, and 10, but the number of lines, of course, that you're using is just lesser than the one that you did then I showed you at the top here. Okay, so this is what we call as list comprehension. So you are utilizing an efficient coding to understand the list by just using this one line of code, this one. Okay, so this is the line of code. So if you're going back to the example hands-on 6 here, so let's try to use the concept of list comprehension and try to print out this value 0, 1, 4, 9, and 16, which is processing the numbers into a square number. So using the square number, so open the bracket. Now it says X. Let's say we just stick to I to say that, okay, this is the variable I'm going to use. I don't want to use X. So for I square, and this will be squared for the numbers whereby all the numbers here comes from range 5. Okay, so range 5 will give you 0, 1, 2, 3, and 4. So using this simple one-liner, we will get our square numbers. So we can print this and then we get a square number. Print that, then you will get those numbers, right? So if let's say you do an adjustment on the range here, let's say from 1 to 5, so that will be 1,6 for the range. Open that and then you print it, you get those values 1, 4, 9, 16, and 25. Okay, right? So here is where we try to use Python for efficient coding lah, in this case. Okay, so next we're going to hands-on 7. Let me check. Any questions so far? No questions? All right. Let's move to hands-on 7. Here, I want you to write a function that takes a list of numbers and returns only even number. Oh, sorry, I think I did the hands-on 7 here. So here we want to write a function called return even number, compose the function to read a list of numbers as inputs and then process the numbers and return only even numbers. Okay, so I was thinking to and forward here. So for hands-on 7, this is the hands-on 7 over here. Okay, these two. The first one that I've done just now is to compare to build a longer code, okay, list of codes, which actually doing the same thing, but you can actually reduce the number of lines by just using this list comprehension method available in Python. So this one takes quite a while to understand, but if you keep on like using for loop and you just need to just read those data line by line, you can consider this. Okay, you can consider this. Right, so let's go into hands-on 8. Here we're looking at working with NumPy and Pandas. So this is already a second part. So let's do a special subsection. Or maybe I did not write this as Python data handling, but never mind. Let's call this subsection 4. Okay, go here and rename this first. So we call it NumPy for numerical computations. You can do more detailed notes if you want to later. Here will be section 5, subsection 5. So during your free time, you can even add more examples for you to further understand and practice your coding on your own. Okay, please do this as a practice now. Okay, so we're going to use NumPy and Pandas. These two libraries are very important library in data science, especially if you want to handle maybe integer, float, and also processing cosine functions, sine function, tangent function, and etc., mathematical functions, and then you want to manipulate it, and etc. And pandas are very efficient when you come to handling huge data set, where you are looking at reading data sets that are being kept in Excel sheet, and they are column extensive. You have multiple columns, maybe 20, 30 columns. So this is where you can manage your data efficiently using pandas. Okay. So let's look at the first example here. We're going to create an array. Okay. Just a simple array using the NumPy. So first thing you need to do is to import the library. And call numpy as np. Okay, and then import another one. Import pandas. Even though we are doing numpy first, we just import both those two. Or maybe I should do it in another one because this is part 5 actually. Okay. Right. Generate another code cell, push it here. Then you put under the pandas for data handling. So you should have something like this. Import it, run it. You can run the pandas later. Right. As a good practice, any libraries that you want to use in your whole experiment on your notebook, you should put it at the top part of your notebook. And you can lump it up all together. Like, for example, you want to import regular expression, you want to import sci-fi, then you can do so. So you do everything over here, run it one time, and then you do your coding, etc. And then if you need another library, you just put it at the top again, so that you know, oh, did I use that library before? Did I use that library before? You know, that kind of question. So better you just lump it up together and put it together. Okay, so going into this, we've done 8. Now we're going to hands-on 9. So let's try to use the NumPy to create array. Array here, equivalent to list, but better. You can do many things over here on the array. You can add the array into a matrix. You can manipulate the array to do something else. Okay, so we can establish our array. Something like that. So you can print to see how it looks like. Print AR. Let's say also you want to be specific with strings to show your array. You can also do so. Oh, what did I do wrong? Oh, come on. Okay, run that and you have your array. Okay. If you have a list, you have to know why you want to establish a list. If you want to use np.array, you have to know why you want to use this np.array, because there are some limitations on if you use a list and then suddenly you want to change it into numpy. Okay. Please be careful on that part. Okay, now we are looking at how we can use element-wise operations. This is something that I think you can do this on the list, but you can do this on an array that you have already established using the numpy. Okay, so let's run this. So we want to look at what are the squared values. So you can put your variable there and just use the double star there to indicate power function, and then you have your squared values. So it's similar as what you have done over here just now, which is by using the one line list comprehension, but you have to use that list comprehension function method in order for you to do an element wise operation, which is a little bit longer. So using list, you have to do something more if you want to do element wise operations. But if you have established using an array, you already understand that this is an array, so it'll be easy for you to do element wise operation. So you have to think of whether you want to come up with a list and then you're going to use that list for something else, not doing any extensive mathematical operations. Okay, then you can use list. All right, so another one, let's look at generating random numbers. We can just use the rand function. So this rand function, this rand function is under numpy. So we call the rand function. Let's say we want to generate a matrix with random numbers of size 5 by 5. So we can print that. Random. And then run. Oh, doesn't look so nice with the \n. Okay, so now you have a random number matrix of size 5 by 5, and you can do other sizes if you want to. So random numbers, I think you should know that random numbers are generated on programming language. Is not necessarily in integer value. So these values are in decimal points. So they are in floats. So if you want to generate random integer, look it up on how to do that. Okay. All right. So let's go into hands-on 10. So hands-on 10 here is to create a transpose of matrix. So you already created a random number here and compute its transpose. So to do the transpose, I think it's quite easy over here. We can just call the transpose function. Transpose function, let's say we call this as a variable transpose rand. So from that random study, because this is a numpy, numpy matrix, so we can just call the subfunctions over here. Just gonna put that as transpose. Okay, and then run this. Then you get some matrix if you print it. So I'm just going to copy this, transpose random matrix. Then we use transpose underscore rand as the variable that you use. So you can print it out. So your matrix is being transposed. You can check whether it is correct or not. So I think it's correct. We have the diagonal values are the same. So this is a transpose matrix. Okay. Right. So that's up to hands-on 10. Okay. So next is about going back to the student data that we've already used on hands-on 3. So this is to use the pandas. Okay. So now we're going to use into the this part 5 over here. So run the pandas. Okay. Oh, what did I do? Input pandas as, sorry. So run that library. So next is you want to establish a data frame using the student data that we've already established at the top. So let's look at that. Let's print out that student data first. Just to recall. Okay, so this is our student data. Now we want to build a data frame out of this student data. We can do that from a dictionary that you've already established. It's very simple over there. pd.data frame. Okay, so that's the sub function over there. So over here it shows that okay, you're using the correct, you're calling this correct sub function. Okay, now we call the student data. Okay, run this. Hopefully it works. Okay, no error. Next, we print our data frame and then run. Okay, so this is how your data frame looks like. I guess you can remember how it should look like. You have your student values over here. So if you realize that it doesn't really look like how your table looks like, but that's fine. Okay, you can actually change how you want it to look like. Okay, if you want it to have, like, for example, student 1 over here, student 2, student 3. But the most important thing, the data are being kept correctly. Okay, so this is the most important one. Now we are supposed to filter the scores. Okay, to filter the scores based on certain criteria. So over here it says that the criteria is to check whether the scores are greater than 80 or not. Oh, we need to, before that, we need to add the scores. Now, how do we add the scores over here? What would be the way to add the scores? Either you want to add the scores on the data frame here, or you can add on the student data dictionary. So let's try to do on the simple one first, add on to the student data dictionary first. Okay, so over here we have the student data. Okay, so we want to append student data. How do I append this song? Oh yeah. Student data update. Where this is using this way. Okay, so let's say I'm going to do this in a simple mode. We're going to copy this. And then let's see whether this works. This is a simpler version whereby we're using the same value that we have just now. And then we're adding another key here. This would be, the key would be scores. First one will be 85. Okay, let's see whether this works. Okay, let me try to print the student name. Okay, we have the scores over there. I'm using the previous cell to look at whether I have already added the score correctly or not. Okay, that's fine. Now we need to add for the other students. So this is the simple way to do this. Okay, we'll go into this a little bit later on how we can manipulate on the data frame. So update on second student. This is the second student details over here. So let's try to use that value. Details. Okay. Oh, I think I did not copy all. Hold on. Computational science. And then two. Okay. Right. So the second score here would be 90. Okay, so I'm gonna do the last one. Student update. So student 3, software engineering. And the score is 78. Okay, so I'm gonna run that. So you should have all the scores over there. Edit, run this again. So you have the last line over there, you have all the scores. So this is how you can actually add by updating the dictionary. Okay, right. So from there, we are supposed to filter based on the scores. So let's say we try to filter based on the scores that we have over here. We have 85, 90, and 78. So high scores that you can get, oh, not plus, underscore scores. Okay, we call our data frame, and then you need to call the data frame again to indicate which column or which key that you want to actually read. So our key that we want to see is scores. Okay. So I did not use capital letter for the S. I'm just going to use the small all letters there. Greater than 80. Right? And then try to print that value. Okay. Run this. I have a mistake here. DF. Oh, that's what went on. See? Oh no. Is it run by student? Okay, this is column wise. All right. Wait, hold on. Let me do something first. Yeah, because I think I should not use the dictionary there and create a new dictionary because the layout is different. Wait, hold on. We try to transpose this. Eh. Ah, okay. We try again. Oh, oh. Hmm. Okay. Try to run this. Default transpose. Okay. What I put there 90. Wait, hold on now. Okay. All right. I did a mistake here because based on my looking at my notes here, based on my notes, I should have established the student data in another way to keep all those students' names. Students' data, sorry, students' details in a different format. I should have just not used the update, but anyway, this one works. Yeah, the idea is to actually get the data frame, and I should have noted that this is not a good way to keep all those values because the scores, the program, the name, and the age is more important to be kept in the column wise rather than being in the row wise. Okay, so I'll take a note there. So from there, what I did was to transpose this. This is actually based on NumPy lah. NumPy transpose method on data frame. It's very simple. You just call it as key. That's it. Yeah. Instead of transpose. Then we transpose the data frame. So the data frame for DF1 transpose should look like, let's try to print that again. Print this. So the first part will be the data frame lah. This part. This is actually additional because we added it just now as the scores. Okay, this part. Let me run this again. Okay, so this is the F1 transposed, and this is the scores value based on the students. All right. So anyway, any case, we managed to print the high scores. So what I want you to do is to think about this later. How do I print the names of the high scorers? Only the names of the high scorers. Okay, so I want you to think on how to actually do that. To just print the high scorers. All right. So I'll leave it to you to do that. Okay, so next. Okay, so this is the part whereby I want you to upload the students.csv on your best is to experience it on Google Colab if you have not done so. I guess typically how students do or the ones that just want to just get things okay, fine, I'm just going to process this once. What you do is normally you just upload and find your data set. That's fine, you can do that. You click on this and then you upload a data set. But when I first did the Google experiments using Google Colab, is that sometimes I do training, it takes hours, and then when I accidentally close the web browser, then my experiment is stopped. Okay, it halted. So when it's halted, not only your data is not being processed, and your Excel sheet or whatever data that you've already uploaded also fill up. That's how Google tried to optimize the space that they offer to people. So what I want you to do is that you connect to your Google Drive. So you see here, you can mount it. When it says mount, which means that you are supposed to mount to your Google Drive. So I'm mounting to my Google Drive over there. It'll take some time, get your credentials or whatsoever. Okay, fine. So it's still mounting. So now you go to the drive and you go to my drive. So you have all your apa namanya, all your folders over here. So I think I put my data in teaching code. Yeah. Let's say you have your artificial intelligence folder. You click on the data set, and then you keep your CSV file in your Google Drive. Of course, you have to do this in another apa namanya, in your other browser to upload it into your Google Drive. That's fine. Or you can also upload it directly from here into that Google Space. Okay, so yeah. So this is what you're supposed to do lah. You download the CSV file from the Elite and upload it, or we call it mount the CSV file. You can also mount it using coding. I can't remember if I have that or not, but there's a way on how to mount your yeah, I have it here. Okay, there's a code here. Oops, let's go down. So you can call this from Google Colab import drive. So that's the library to call. Then drive dot mount. Oops. Bracket slash content slash drive. So what it tells is that, okay, I want my drive to be mounted. You can run this and then you will have the same thing. You can see the same thing. Okay, either way, you can do it over here. Okay, you have your UI to help you to initiate that. It's the same thing. Okay, you can run that. I don't want to run it again because I don't want to be logged in, sign in again, blah, blah, blah. Okay, so right now is we want to try to read the file from the Google Drive. So let's try to read the file. Okay, so we're going to use the data frame again. So I call data frame df1, df1 PD, maybe call it student ID last, student ID, student data again. Okay, if you don't want to rewrite pun tak apa. So I'm going to call the PD, the pandas, the function read file, read, not only, but read CSV because it's a CSV file. So they have a way of reading CSV file, which is nice. Now we need to write the path here. So since this file is in your Google Drive, you can get the path over here. You copy the path and then you paste it here. So that will be your path to your CSV file. Okay, it'll be easy for you to do that. Okay, so let's try to run this, see whether we have any mistakes or not. Okay, fine. Now let's try to display the first 5. First 5 rows. Okay, to do that, you can run student, you can call the student data frame again, student underscore data dot get 5. So run that, and then you have a very nice things happening here. Okay. Right, so we've already done the read the file, display the first 5 rows. Okay, so the first 5 rows will look like something like that. The CSV file, if you open the CSV file, you have that same information. Maybe some other students already added into that data. So using the pandas, you are now have a lot of interactive things that you can actually do. One is to convert this data frame into an interactive table. Second is to suggest some charting methods. And you can even generate code with student data. So generate code with student data actually allows you to do a prompt. on this Gemini AI to help you to how to manipulate this data frame. It's interesting, but use with caution. And you can also use view recommended plots they want to recommend based on the data set that you have. So there are many ways on how to do this. That's why I like to use Google Colab, because they have all these smart things that you can actually do, but you have to use it in caution. And you have some other interactive sheet. This one actually connects your data set to the Google spreadsheet. So I leave it to you to explore. You can do that later. Okay, so what you want to do right now is next is to filter students based on age criteria. Okay, so let's try to filter that. Student data, SD. So I call that as filtered underscore SD. Okay, so we have DF, not DF, student data. And then call again student data specific to the age group. Age here has to be capital. And then the condition is maybe we set this as 25. Then let's try to print. Okay, it says empty because nobody is more than 25. Let's say 20. Okay, so we have some values over here. So this is how you actually print students' list based on age criteria. Okay, so that's hands-on 12. So hands-on 13. Okay, this is supposed to be 13. Sorry, not this is 13. This is supposed to be 13. Okay, let me update that again. Okay, so hands-on 13 is related to using data visualization. So this is going towards data visualization using matplotlib. Okay, so let's name this as another subfunction, not name, but give us another subsection. Previous one was number 5, so we can call this as number 6. Okay. All right. So from here, you're actually using the maybe open this up again. So we are looking at the basic ways on how to do data visualization. Okay, so I think I left this hands-on the thing for you to do. Basically, we're using matplotlib where you can do static or animated visualizations. Okay, and if you want to use Seaborn, this one works very well with data frame. This one is what I can remember. It works very well with data frame. Matplotlib, sometimes it's very restricted where I don't think you can understand data frame very much. And Seaborn can help you on that, especially when you have a lot of data that you want to plot and you can't expect to use the for loop or the list comprehension all the time. So it can work well with the data frames that you are actually using or any arrays, and it can even do some semantic mapping, which means it can understand any implicit things in your data lah. So implicit results, something that you have not discovered based on your simple analysis. So it's nice to actually learn how to use the Seaborn. Okay, so if you look at hands-on 13 over here, you can load your matplotlib. And for this hands-on 13, you need the NumPy, so you just load it up. If you have not loaded it up yet, if you already loaded it up, then fine. You don't have to call the library. So this is just to generate some linspace. I believe you have already used linspace in your CS lab, if I'm not mistaken. So linspace is just to come up with some x values from 0 and the step is 10, if I'm mistaken, until 100. So you will have numbers from 0, 10 until 100. Okay, on the y value, this is running the sine function. So we can use NumPy to generate us those values based on the x values that you've already inserted here. Then you can plot the function. So you have a very sinusoid sine function wave over here. Okay, and it's very simple. Okay, so I think you should know how to do this already. So hands-on 14, not 13, is basically to modify the code to plot a cosine wave. This one I think is so easy. What you need to do is to know how to call the cosine function in NumPy. I believe it's just using cos or cos. Okay, you just need to change the sign into cos. Okay, so I leave it to you to do for hands-on 14 and hands-on 15. Okay, 13 and 14. Okay, so here hands-on 15 is to plot the bar graph and histogram using the student's data. Right, so this one, let's continue from where we left off. Okay, so here we are importing the matplotlib. I have not done that yet, so I'm going to import that. So I'm using the pyplot and import it as plt. NumPy no need. Keyboard yes. Okay. All right, so here I'm going to use the student data data frame just now. Here you have the DF. I've already renamed it to student data already over here as the data frame. So I'm going to use the same one, or else you will detect a different data frame. So dot plot, then we can add in the parameters. So what type of plot? We're going to use a bar plot, comma, and what are the x values? Not values, name, okay, or the label. So we call that as name. And then for y is equal to scores just now. So we name the label y as scores. Then title. This one is to keep the label for the graph itself. So we call it student. Okay, let's try to run this. Hopefully it works. Name PLT is not defined. Oh, forgot. Run that. Run this. Okay, so now we have our plot. Okay, so this is our matplotlib plot. Okay, this is based on 3 students. Mine, because I already have other students in the data. Okay, so I have more. So this is just a sample. Right, so next, let's say we want to have a histogram. So histogram using the DF, using the student data. So histogram, I believe that there's a difference between just a simple bar chart, okay, something like this, and a histogram. So a histogram must have some mean function over here, okay, to give us some semantic meaning on the bar graph itself, okay. So this right side will be based on the seaborne plot. So we're going to call SNS dot histoplot. Then we call student data again. We're going to plot the scores. So we can set our beans. So beans will be the distance between one histogram to another, if not mistaken. We'll look into that. I remember. True. Okay, run this. Okay, right. So this is our histogram plot. our beans 5. So because we have more than 1, 2, 3, 4, 5, 6, 7, basically more than 5 students. That's why you see the beans are very close to one another. You can further increase this, maybe 10. You will see that we have a different way of plotting. So the distance between each of the beans. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 beans. They will distribute the beans according to the names of the students. And this is the how the histogram would look like lah, based on the uh, y values over here that is stated from 0 to 2. So 0 to 2 doesn't reflect the real scores of the students, but it gives you an idea. So Seaborn is more semantic analysis on the statistics, while Matplotlib gives you a very direct statistical analysis on the data that you have. So if you want to have more meaningful statistical analysis, I suggest that you learn more about what is Seaborn and how it can actually help you to give more insights, provide more insights on the data that you have. Okay, so that's the difference between Seaborn and also Matplotlib. Okay, any questions so far on this part? Okay, so the question I put in this slide, I want you to think, and I think you know how to do this. How do you change the color of a graph? It's very easy to do. Okay, you can Google that, or you can try, asking Gemini on how to do that. That's fine. Okay, now I think I don't have time to go for SciPy. I'm gonna leave this for the next class. Okay, so because it's already 1:53, probably I'm doing a little more hands-on than I'm supposed to do. Okay, never mind. So we will leave SciPy to the next one, because there will be another practical session on Thursday next week, where I will look into some introduction on scikit-learn, and also teach you more in depth about data cleaning, because I think that is quite important today lah. You need to know how to clean data, normalize data before you start to do your AI experiment, especially if you want to build machine learning models, any machine learning models whereby you're going to use naive Bayes, or you're going to use random forest, for example. You still need to make sure your data is clean or valid to be used lah. Okay, right. So what I'm going to share is why this Python notebook is nice to use. Is let me go to my one of my documents. Hold on now. At the same time, I want you to ask any questions related to this. Is my pace too slow? Is it too fast? Okay, thanks, Rebecca. Okay, give me a minute. 1 minute. Mm. Uh, okay, so I'm going to show you my students' work. Yeah, I'm supposed to publish this, but I haven't published his thesis yet. He's already busy. He finished his masters and he's now project manager in one of the oil and gas company. So we're supposed to publish this on his GitHub, but he has no time to do that. I have the thesis. I'm supposed to publish the whole of the project, but I haven't done that. But anyway, what I'm trying to say is, building a notebook is really good because it really gives you the idea of your project properly. And with the notebook that you have, you can actually build really interesting information on your project and how to actually run your project. So this is basically what he did for his 2 years of work. It looks simple, but actually no. Because he was training a model using Nemo's speech recognition engine. You can look it up actually. So this is open source, and there are many pre-trained models for speech recognition. And he was doing speech recognition trained on my dataset, which is IBAN language speech recognition dataset. So he did all this to train a model using the Nemo speech recognition engine from scratch and also based on transfer learning. So he did the setup. All these are being done based on his experiments throughout the 2 years project lah. Okay, so this is after the training, and he got the best result already, and this is the result of the transcribing sentences, some of the word error rate evaluation that he has already done. Okay, so evaluation using some SCTK method, not method, tools, and some samples on how to actually run the model. Okay, so another student of mine, she's still doing her corrections. So she just defended her thesis. So she built a Malay English social sentiment corpus using Twitter data, now called X. So she collected the data for a few months, not a few, but quite a long time actually, in 2020, between 2022 to 2023. So I can share with you this link. You can go ahead, you can use this, get some idea for your project. So this is a code switch data set, and she has published a notebook over here. So she is going to publish another paper. First paper already published, second paper coming soon. And she has provided a GitHub here, a Python notebook where you can experiment using her sentiment corpus. So she has lined up all the techniques that she has done. She did a comparison between all these techniques to see which is the best one. Okay, we train support vector machine, random forest, etc. So all these were done using her corpus. So her contribution was the corpus and also another method in identifying the best way to identify pseudo labels for her sentiment corpus. Yeah, so all these are actually interesting, and she has done her experiments using Google Colab. Yeah, basically using Google Colab, and Steve was doing the Nemo one, so he did his experiment using Jupyter Notebook, also sometimes using Colab. Yeah. So yeah, that's it. So I'm gonna take your attendance. If you have any questions, just let me know.
Hello, dear doctor.
Yes.
I'm Wong. For the assignment and project, can we use the Hugging Face models to train some models?
You can, but you have to be careful if you use Hugging Face. Just check whether they will charge you or not.
I mean, yeah. I just use the free API to use and to train the models.
Can, you sure?
Okay.
Can. Boleh.
Okay, thank you.
Okay, I need to do some modification because it's already after 2. Right, I'm gonna. Okay. Being kicked out from the QR attendance. Wait, hold on. Okay, so try to scan this. So after you scan, you can go. Look forward to see you next week on, next week on Thursday. So we do another second practical.